Well, thank you. It's such a pleasure to be here today. It's my first crop protection forum talk, so I want to thank everyone for making it possible, everyone here today. I'll be talking mostly about red-legged earth mite, but I've been taking some notes today because I find it really interesting. I'm representing sort of like the invertebrate camp, right? But we know that it's all mostly about weeds and diseases. So I've been taking some notes today. Although my talk is about red legs, I'm hoping that I can kind of try to bridge the gap within the three kind of groups, and just based on some comments that I've heard today. So see how that goes. So a lot of talks about resistance, right? So in this next slide, what I tried to do was to kind of like show that this is a global problem, right? And that for all of you that you're now thinking, oh, look at all the weeds, they're globally, right? Like the pests and resistance problems, they're global, right? So here we kind of relate. It's a global problem about resistance that crosses the three groups. And now while here I'm talking about all these species of invertebrates, right? I hope that you're imagining all the species of weeds that you have and all the species of diseases, whether they're soil diseases or airborne diseases. So it talks to this kind of big picture. For insects, for example, we know that it's over 500 species of invertebrates that have developed resistance. So I have no idea how many weeds have developed resistance. I'd love if someone knows who would like to share that, or how many diseases have developed resistance, right? So like they come together as these big things that organisms are developing resistance. Somewhere in there, now again, interesting to see how it relates to weeds and diseases, there is a beetle that has developed resistance to 30 chemicals, 30 mode of actions. It's just incredible, mind-boggling. And another thing that I've seen today a lot is these metaphors that we're using to discuss what I've referred to. Someone described it, Sam this morning. Sam, you describe it as a battle. So the battle for resistance, right? That was your metaphor. Some colleague, Paul from Bayer that I met today, discussed it as like, pests are keeping us on our toes. That's the metaphor, right? Like, so well, I had a different one. I have this sailing racing one today. Funny how we go, right? Like chemicals become available, and what are we racing? We're racing evolution. So there's two natural processes, right? It's the humans trying to do something, trying to catch up with nature doing its own thing. And AHRI made some really good insights into how this is happening at the molecular level, right? So again, could we find a unified metaphor across the three groups to kind of discuss this problem that we're having, which is universal across the groups? So yeah, I just wanted to hope to put my specific mite that I work with, the red-legged earth mite, in the context of grains. And here another metaphor, right? The big four. So I wonder what the big four weeds are, the big four diseases are. These are just, like the ones that are relevant as invertebrates. And we heard about green peach aphids today as well. So yeah, obviously we have, and someone mentioned also today that they found it mind-boggling the number of mode of actions that we have when we deal with pests, invertebrate pests. We have a lot of mode of actions. And this is just to show again, like it's very clear, right? Like insects keep evolving more and more resistances as we start using them. In the case of the red-legged earth mite, there's only 2 so far, and I'll be discussing more about that. But obviously there's other species that are prolific at evolving resistance across the board. So I guess another question that has been discussed today a lot is, why are we here? And well, another common theme, right, across the groups. But this one is slightly more difficult. I'm trying even finding difficulty sometimes discussing this across the groups, right? Because with invertebrate pests, we discuss a lot about broad spectrums. The idea here you see in purple, red, and blue are the broad spectrums. So 3 chemistries, and they're basically taking in the majority of the usage, right? So how can we translate this analogy to fungicides and herbicides? Is there any way of that concept of broad spectrum? It targets the pest, but it also kind of is efficient against everything else in the environment, all the other invertebrates, the beneficials that we'll be discussing shortly. What kind of analogy we have that with the other groups? Or whether that's even possible to kind of like convey to people interested in these topics. And then I think this is also across the board, right? This idea that we are increasingly having less mode of action and active ingredients registered, right? So the attention here is on the sort of the green line, which is active ingredients, but the mode of action ingredient across the years is becoming flatter and flatter. So that's going to be increasingly a problem, right? Now moving into specific about the red-legged earth mite, again, this is such an interesting topic because I really loved how already Chris and Gina and AHRI, have discussed a little bit of red-legged problems, issues. This is a pest that is actually quite new to me. I actually saw her only about 2 or 3 years ago, a week after I started working in Cesar. One of the first things I did was to go to the field, see if I could find red-legged. And it was late in the season, so there was not many of them in the actual crop. But my colleague at the time took me to the fence line where he was convinced that we will see them, right? And we went to a cape weed or another weed, talking about weeds, and we find heaps of them, right? So another point of synergy, right? We're discussing about how to get rid of weeds. We are very interested in that too. I mean, it would be really good management to get rid of the weeds that are also good at attracting the pest. So I think there's multiple reasons here to kind of think how can we manage weeds, right? Not just for the sake of the problems that they do to the crops. So I have the pleasure of leading this project funded by the GRDC and with contributions from MLA and AgriFutures. Now I'll be discussing a few things that we've been discovering through this project with you. All right, so here is, and again, pleasure that some of you already spoke about the actual issues with this mite. So as I mentioned, it's one of those things, right? I think for people actually with their hands on the ground, growers, advisors, it's being able to go deep into the ground and just actually find these things. They're so small, right? So the importance of being able to ID them, there's species that look similarly, but the damage then, when you combine it with the damage that you can see here in the plant, they're quite noticeable, right? So it's again a big issue of how to bring the importance of something that is so small and potentially difficult to identify. Now I loved, Mark, your beautiful plots before, right? You have real-time aspirations to map resistance, right? This is, I guess it's the best attempt that we have here. This is not, it's not an online tool. But we do have these pipelines at work at Cesar where we can update resistance as data becomes available. So this is fresh for you today. This is the most updated map of insecticide resistance and red-legged earth mites for SPs. So you can see that big picture there of it being very prevalent in WA and here in South Australia. Not quite in Victoria, right? I'd love to see what we'll be reporting in a year's time. But you see that we're trying, right? We're trying to find it. It's just not quite there. And I think there was another really interesting comment. I think it was you, AHRI, who mentioned that, was it that it came from South Australia in 1917? South Africa, right. So it means that this species now has been here for over 100 years. And it has spread, obviously, and now has evolved all this resistance in only 100 years. It's quite an incredible feature. So again, and this is the same for OPs, which you can see then clearly that it's beyond WA, South Australia. It is definitely in Victoria. And one wonders again whether it might spread north into New South Wales. So we also mentioned about trying to detect, right? There's been a few conversations about detecting resistance kind of proactively. So this is our attempt to do exactly that. And we're starting to test for neonic resistance too, and so far tested just a few populations, but haven't found it quite yet. Now there's previous conversations about dose response curves and the effect of different, the mode of action mechanisms. So I'm really grateful for those of you who already explained this really clearly. The reason I brought it up here though is kind of I was just trying to think, how can these kind of very scientific dose response curve and these mechanism explanations, everything can translate to practice, right? So I'm going to try to make at least one connection. Why here it is important to even pay attention to this plot and understand why that difference between an OP being only a factor of 20 against the SP, which is a factor of over 50K, right? So in that there is a little bit of, I'll just invite you to kind of cling to this idea for a moment, and then we'll come back to it when it comes to practice. Now, as a matter of a little bit of a summary to finish this section then, I just want to summarize here so you can clearly see here, these are the 5 chemicals that we have available to control red-legged mites, and we already have 2 with resistance. So again, that common thread across the groups about available options, evolution of resistance, and how the future is going to look like. All right, so let's talk a little bit about IPM and resistance management, which is obviously critical to prolong the life of insecticides or chemicals more broadly. So, and here this is probably potentially for me the most interesting one, right? I have notes here because I really want to get this right. Our fungicides colleagues, right, Tara and Fran, you both brought up this idea of the fungicide 5, didn't you? I thought that analogy was great. I kind of tried to simplify the story. And then just now, we were speaking about the big 6. Was it Mike, right? Like just now. So we have these analogies that we're using to try to simplify when we talk about fungicides, herbicides. My poor attempt now is going to have to provide 3 tips, right? This is just in the context of my colleague Lizzie Lowy at Cesar trying to kind of like say, let's communicate this, like she's the extension lead. But I was guessing how good it would be if we had like these kind of things across all chemicals, right? To communicate like things that are in common, right? Like there's one common before, for example, one of the big 6 is rotate herbicides. It's exactly what I'm going to say in a moment. Rotate insecticides. So this is common themes that I'm quite interested in. In the case of the mite, come back to the mite, obviously to be able to use chemicals strategically, we need to know our enemy, right? We need to know what we're dealing with very carefully. In this case with the mite, we know the life history pretty well, which has allowed us, very clever people, to develop these tools, right? In this case, some of you are very familiar with TimeRight. My next slide is going to be about the hatching tool. It's being able to develop things that will assist us really think strategically when we spray. So I invite you, this is work done by my colleague James Mino and colleagues. I invite you to go to the Cesar website and actually start using this tool if it's relevant to you, or even relevant of the thinking of how we can, latch to a life feature of the species. In this case, I predicted here, the past season's hatching time for the red-legged here in Adelaide, and you can see it says 8th of May, right? So we can have a really good idea of when best to spray, when to use that chemical effectively. So this is just an example of tools that we are working on to be able to do this. Now my second tip, which is again this idea of mix rotate herbicides, right? Mix rotate. So it's swap your players, right? Another analogy. We have all these mode of actions that we know are relevant and available, or active ingredients. And we have these strategies that we have developed, right? In the screen, you have a very clear example of a very dire situation for our pest specifically, right? Which is dual resistance to SP and OPs. So then we provide very clear strategies across these windowings, right? But I like that it's talking to something deeper, which is we have that common problem across all the groups that we need to think about how we rotate chemistries. And then finally, and it has been brought up a few times too, is this idea of use your allies, right? So my colleague Rosie Knapp had the talk about beneficials, for example, before. My colleague Evett spoke about beneficials for BGA. And yeah, so that's something that is so important. But then again, and I've been speaking to a few of you today, how difficult it is to translate that analogy to weeds and diseases, right? We don't have exactly that equivalent of who are we supporting if we don't apply it too much. We're doing other things, but unlike with invertebrates, where we're really concerned about supporting, promoting, preserving beneficial insects. So there's a little bit of a challenge to bridge across the 3 groups. And I've been asking whether there was some kind of equivalency of something that is beneficial that you would be able to communicate. Now with this third tip comes like a little bit of like a side story there, which is use your allies but avoid friendly fire. So I was hoping to share with you really fresh research that Rosie has been leading And so I present you with one of these beneficials, right? One of these friendly. In the case of red-legged, is snout mites, which you see here, this little red mite here. And then how we have mapped with that kind of more quantitative approach to the toxicity table that you've been seeing today, all these different active ingredients, right? And then we're very, we can use the analogies because that's exactly what the EOEC is doing, right? Is saying, well, if it falls within this bracket, then it's harmless. If it falls within this bracket, it's harmful, right? So, and we use this kind of traffic light system of saying, well, here you can see a series of chemicals, right, that are harmless. They're green to this beneficial. But then down the line, you see things that are most definitely harmful, right? And then things in the middle. So this is the type of thinking that we're trying to do for beneficials, is to have one of these for each beneficial and to be able to know exactly what are the consequences, right, of your decisions when it comes to selecting chemicals. So just as a summary, lessons learned, there's not 3, I put one more. It's this idea of using chemicals strategically, rotation across the board, following guidelines of the resistance management strategies, and in our specific case of invertebrates, preserve beneficial organisms. Now, just to finish, I just want to plug in a new project that we recently got funded through the GRDC, which we're going to be looking at in really good detail about the effect of aphid parasitoids in canola. So assessing both ecological and economic benefits, as Mike was discussing before, this idea of yield, and I'll definitely love to talk to you about that. But so anyway, if you work with canola in Southeast Australia, please come and talk to me, and I'll love to hear whether you'll be interested in being part of this very exciting work that we'll be doing in the next few years. So thank you very much.
We have an opportunity for a couple of quick questions, starting with Lisa down the front here.
From the online audience, how wide is the hatching window of RLEM in autumn?
Oh, I don't know exactly. Yeah, I'll have to use it and then find out. I know that the tool allows for historic windows. So it tells you a little bit of 50% of the times it's followed within this window, and then I think it's 90% of the times. So it gives you a sense of the history of the hatching in the past.
Wouldn't it be great if we had a web page that showed the distribution and had the tools all linked down the side? Just a suggestion. Any other questions? Okay. Oh, sorry. Yes, please.
I've got a left of field comment, right? So you were talking about, well, can we, what are the natural enemies? Of course, there are many natural enemies of weeds, and of course environmental weeds are largely controlled in many cases by invertebrates. So have you thought about thinking about trying to combine those in a way? I mean, I can just imagine creating an invertebrate that's actually better at attacking ryegrass.
Well, exactly. That's the type of questions I think I've been trying to ask some of you today, right? Whether that's equivalent of a potential beneficial insect that could also be controlling a weed, and then we can get those synergies across the groups, or even potentially insects that might be feeding on fungus, right? And then we can get a conversation about the benefits of insects beyond just controlling invertebrate pests. So I think that's what I was trying to allude to.
Okay, I think we'll end up there. Thank you very much. Thank you.
Thanks.